In this question, we're going to do anti-by recognition. In this case, you're being asked to differentiate an expression and you are told what the answer is. So you're asked to show that the answer is correct. So carrying out that derivative and getting the answer as expressed in the question is what is required for part A. It then says to us, hence find the exact value for part B. Hence means using the previous result. If you couldn't get the previous result though, they have told you what the answer was to part A, what you were trying to show. So nothing would stop you taking that thing that you were going to show, even though you couldn't, and use it to get the second part of the question. So here we go. We're asked to differentiate the inverse cosine of the square root of 3x. So the way we're going to do this is we're going to use the chain rule. So we're going to let u equal the square root of 3x. So if I differentiated that, I would get du dx. Du dx would come out to be root 3 on 2 root x. Now, the other thing I would have would be y would equal inverse cosine of u. So dy du, using our derivative formulas for the inverse of cosine, what we would get is -1 on the square root of 1 minus u squared. That means the derivative of inverse cosine of the square root of 3x would be equal to dy du, -1 on the square root of 1 minus u squared, times du dx, which is root 3 on 2 root x. Now, we know that u was equal to the square root of 3x, so we just need to tidy this up. -1 on the square root of 1 minus u squared. U is the square root of 3x, and we're squaring that, times the square root of 3 on 2 root x. This means our top line will become minus the square root of 3. Our bottom line, 1 minus the square root of 3x, all squared. That will cancel each other out, leaving us with 1 minus 3x times 2 root x. That gives us negative root 3, all divided by 2, inside our square root sign, 1 minus 3x times x, which is x minus 3x squared. Comparing what we were asked to show and what our answer is, you can see they are the same. So we have shown that is true. Now we're going to move on to part B. Part B says hence using. So you must use the result that we have just got. If you did it any other way, you would be incorrect. So the integral 1/4, 1/6, 1 over square root x minus 3x squared dx. Now what can we do? if we have a look at what we're asked to do and what we've just got, you'll see there are some similarities. On the top line, though, what we're asked to anti-differentiate has a 1. On the result we've just got, there was a negative root 3. If you look on the bottom lines, there's no number in front of the square root of x minus 3x squared. That number is 1, but there is a number other than 1 on the result that we have just gotten. So again, this is using one of our mathematical tricks. We know an antiderivative that has a very close similarity here. So it's going to be some manipulation. 1 is equal to something times minus root 3 over 2. So what do I multiply negative root 3 over 2 to give myself 1? Well, that would have to be negative 2 over root 3, because they would cancel each other out, leaving us with the 1. So what we do here is we say the integral of 1/4 to 1/6 of, I'm now going to write negative 2 on root 3 times negative root 3 over 2 root x minus 3x squared dx. We have not changed the problem because those two things multiply together to equal 1, which is what we had in the top line originally. So I'm going to write the negative 2 root 3 outside the integral sign as a constant. This has now become a much easier question to solve because we know our answer from part A and what we now have in the integral sign are the same. So what that tells us is if we differentiate the inverse cosine of the square root of 3x, we get our answer to part A. So if we anti-differentiate our answer to part A, it takes us back to the original. So this tells me minus 2 root 3. Now we know the antiderivative, because of our work in part A, will be inverse cosine of the square root of 3x, and that's from 1/4 to 1/6. So we are now ready to substitute numbers in. We have minus 2 root 3 times. If we substitute in 1/4 for x, we get inverse cosine of the square root of 3 on 4 minus the inverse cosine of the square root of 3 on 6, which is minus 2 root 3 times the inverse cosine of root 3 on 4. Root 3 on 4 is equal to the square root of 3 on 2. The inverse cosine of the square root of 3 on 2 is pi on 6 minus, we've got the square root of 3 on 6, which is the square root of 1 on 2, which is 1 on root 2, or root 2 on 2, if it was rationalized. So that is inverse cosine of 1 on root 2, which is pi on 4. So we have negative 2 over root 3 times pi on 6 minus pi on 4 is negative pi on 12. Multiply those together, we get pi root 3 on 18.